Hello. This really isn't easy. I have no idea why my video was taken down. I did write them and ask them to review their decision. I don't know how you found me. I guess, anyway, you guys are clever. But I'll deal with the other video in due time. Bear with me. I like this method. I prefer this to Google Meet. I did a Google Meet meeting today. Did not enjoy that. I couldn't connect for some reason. I have my whole computer set up for YouTube, and I don't know. Some of the settings wouldn't change to meet in the Google chat room. So you can hear me, right? What I said I would do today, and it's in the agenda, that I would show you how to use the calculator. Let's see, I have the calculator on my iPhone. So I made some comments before they deleted my video. I made some comments that you can buy the calculator, the TI BA2 Plus. You can buy it on your iPhone. I'm fine with you using it on your iPhone. You have to discipline yourself if you're taking a test not to use any other feature. But given this the unusual circumstances we're in, I'm fine with you using the phone. So how many of you have a BA2 Plus? How are we going to figure that out? There's 9 of you. Okay, so I'm gonna anyway, put it in the chat if you have one. Say yes, I have one, so I know how many of you there are. If you don't and you have $16 and you have an iPhone, you can buy this one. That's the application. If I have to write it again, this is for the TI BA2 Plus. If you have another calculator that you want me to help you with, we can do that separately, maybe after the hour. I'll meet with people. I don't know. We can try to do this. I don't know. I don't know. We'll figure something out. Maybe for 2 people, we can do a Skype or a Google Meet if you really need some help. But let me know if you have a BA2 Plus. Good. Okay. So this is going to be great. And do any of you know how to use it to find the correlation and the prediction line? Any of you know how to use it? So I'm going to feed the video. You're going to have to watch carefully and follow along because it's dark. It's a dark screen. You're just going to have to see that certain keys are highlighted when I enter the data. Some of them won't be, though. I don't know. Looks funny. Okay, so you don't know how to do it. Okay, so remember how we entered the statistical data. So let's use that approach. I wanted to use the example in Unit 3. Unit 3, the example is on, just give me a second. I'll tell you what page. So there's some data that I give, and I ask you in the notes to play with the data. So these are pages 25 of the notes. I'm going to bring it up so you can see what I'm looking at. You can hear me good? So let's see if this is easy enough. You see that? Okay, so page 25. Oops. I have to scroll forward. Oh my goodness. Sorry I don't have better features or a good stylus. I haven't slept out of the house to buy anything. I'm gonna search around on the internet for a better stylus. I lost the one I had before. Okay, so page 25. Loud and clear, so is it too loud? So there's data here, and I put together so there's this data here, and I have all these formulas here. So the discussion that goes with this, I've presented this in exercise 4 and 5. This is financial data. This is really important as an application of statistical methods in business. But it's also very, very useful pedagogically to distinguish between ex post data that looks like this and ex ante data that looks like this. Okay, so what's the difference? What is the difference between ex post and ex ante data? Well, you see here, the way that it's presented, every observation is equally important. In other words, every observation contributes the same value of information. Okay, so I kind of repeated myself, but there's no difference in each point, each observation here. So when the S&P, which is a measure of the state of the economy, when it's 15%, this company's stock is 30%. Okay. So this is BCE, it's supposed to be Bell Canada Enterprises, and so on. So that's the sort of data that's in ex post. Ex ante, so you can use your Spanish to help you. This is before the fact data. So ex post data is after the fact. So this is historical data. This is what we already saw. Using historical data together with economic predictions, together with potential financial records of the firm, okay, prospectus, we can create ex ante data. So this is a prediction of what's to come. Okay, so before this event has happened, this is what we prognosticate. This is what we anticipate. We anticipate with 40% probability that there's going to be like a expansionary economy, a boom. All right, so when there's a boom, the market indicator is high relative to the other times, and also BCE does well. Okay, in a normal state of the economy, with 50% chance, the economy will, the index will be measuring that the economy is growing at 8%, or there's an 8% return, let's say it that way, sorry. And then for BCE, the measure of returns is 18%, okay? So, and then recession. So this is an example of ex ante data. Notice I only tell you about 3 possibilities. In fact, this is an example of a discrete distribution. Okay, this is a discrete distribution. So this is discrete. Okay, and because I'm not supposed to assume you have calculus background or you have any advanced mathematics, these are the examples I'm going to give you. But if you were to go on in a course in statistics, you wouldn't use just the discrete case. You could use the continuous case. So actually, some distribution could be used for probabilities alongside these outcomes. So anyway, so this is actually as intimidating as these formulas look. This is an example that's very simple. It's actually very simple. Okay, so what's going to be different now, and we did learn about this in Unit 2, is that formulas for this up here are just a straightforward sample standard deviation, sample mean, sample covariance, which I mentioned a little bit above, and I'll talk about it a bit more. And these are just different forms of the formula. So all these forms of the formula, as intimidating as they are, these are all the same, okay? And I did mention them yesterday. So what about down here? These are the equivalent formulas, however, as weighted. See, so you use the weights here, which we talked about in Unit 2 GDS. These are, this is the weighted mean here. This is the weighted standard deviation. This is the weighted covariance. This is the weighted correlation coefficient. And this is called the beta. So up here I call it the slope, but here I use the letter beta. So all the symbols here are Greek letters, whereas these ones are lowercase alphanumeric letters. So what is that implying? Well, when do we see sigma? What is sigma? And here, I didn't put it here, but this is also could be written as mu. Okay? So in fact, these are population parameters. These are parameters based on the fact that I believe this distribution is representing the population, about what the possibilities are. Okay? Oh, thank you. So I'm going to move that up. I'm going to move that up. Okay, so this is what I've been talking about this whole time. It's going to show in a second. Okay, I have to pay attention to the view. All right, so you should be seeing that soon. So this is discrete. So again, repeating these formula. So I mean, you have it on your document, right? Page 25. Please follow in your notes. Please follow in your notes so you know where this is. Page 25. So I'm going to assume you have the notes, but maybe I shouldn't. Anyway, so these are the formulas, and because I have all the information on the possible outcomes, all the possible outcomes, there's only 3. It's not infinite. I treat this as a distribution of the population, and so these are parameters, okay? And I use the information given and calculate population mean, population standard deviation, and then the population correlation coefficient, and then the slope, which I now call beta because of the Greek letters. Okay, so take some time to think about all that later. Right now what I want to do is use these values to compute with your calculator. Let's work with the first one, okay? So with the first one, I want you to enter this data. So you're entering this data with your TI-84. I'm going to open it up now. Okay, so this is my calculator. How's that? Okay, hold on, I'm just getting the calculator to show. Not sure why it's not showing. We're waiting for the calculator. Aha. Okay. You see that? These things should be much more seamless, but I'm just learning. No excuses. I don't know. It's not showing yet. Ah, you see it. You see the calculator? Oh, now you see me and the calculator. Okay, how do I do this? I'm gonna make it smaller. Do I make it smaller? How do I make the image smaller? I don't actually know which one's working. Okay, well, enter the data. I don't know. Uh-oh. This is not going to be cool. I need to shrink it. Oh, now. So if I go like this, can you see that? And this. I need to practice more with this. Okay, now how do I make it smaller? Is John there? How do I make this smaller? Maybe I shrink it somehow? Oh, I don't know what. Why? Oh, I can't make the thing smaller. Is that gonna work? Okay, I think I'm just gonna end up instructing you. I can't shrink it. I don't know how to shrink it. I don't know how to shrink it. It won't shrink for me. I'm trying trying to grab the edges. I did? How about this? Okay, so if I go like this, it's going to shrink. Let me do that again. Is that making it smaller? Okay, somehow it's working now. I don't know why. I don't know. I'll figure it out later. Better? Just like, I have like two. Okay, this one. There. Is that working? I'm in the background. Yeah, I'm getting the hang of this. Uh-oh. Sorry. Is that better? Now can you see? All right. So now enter the values using, uh-oh. Okay, so enter the values using second function. Okay, and then data, and start to enter the numbers one at a time. So we're going to do the top exercises. So to enter the values, you can enter them either as 15 and 30. So you're going to enter X as 15. Press enter and then down. Now you're going to enter the Y value, 30, enter, and down. And that's it. And keep going. 9, enter, and down. And the Y element, 18, enter, and down. And then the third pair, 10, enter, oops. 10, what did it just happen? 10, enter, and down. And then 20, enter, and down. And 8, enter, and down. 16, enter, and down. Something happened. Fourth, oops, I don't know, I might have hit plus by accident. Okay, so let's go back. Let me see what I have. So I can use the arrow to go down. So second, data, and I can check what I have in there. 15 and 30, 9 and 18, 10 and 20. Oh, that's not right. 20, enter, down. And then 7.5, oh, I missed one. 7.5, enter, down. And 15, enter, down. And finally 8, enter, down. And 16, enter, down. Okay, so you try that. This should be 5 observations. So I'm going to repeat, I'm going to look at them by hitting second and data, starting at the beginning and making sure I have 15 and 30, 9 and 18, 9 and 18, 10 and 20, 7.5 and 15, and 8 and 16. Okay? So that has all the observations in there. Once you've done that, now if you remember doing this for the mean and standard deviation, you just have to hit second stat, and it says LIN. What does LIN stand for? Linear. So what you can do is scroll through and see your linear results. N is 5, X bar is 9.9, SX is 3.0083, sigma X is 2.69. Okay, so that's everything for X. And then for Y, there's the mean, the standard deviation, and the variance. Okay, so that's the difference between SY and sigma. Remember, we discussed this, but now you have them for both of the variables, for the X variable, the variable X, and the variable Y. Okay, so you have all that information. Does everybody see where I pressed? It's highlighting, right? So if you need to go back and scroll through and see what I did, just look at my highlights with the calculator. So let's confirm that's actually those are the answers. So I don't have the answers in the notes, but what I did is I put them on the Moodle page. Okay, on the Moodle page you can download the solutions to this. You can also take an opportunity to familiarize yourself better with these formula by using the spreadsheet that I attach on the Moodle page and calculating them using the spreadsheet. You can also try it by hand. Now on the test, I'm not going to ask you for anything like that by hand unless I give you a very, very simple question with 3 values or three observations. I'm not going to give you a long one. This is pretty long. So you can confirm that you understand the calculations and what they're doing. Okay, so those are the mean and standard deviation. So that's nothing new, except I've done it for X and Y at the same time. If I keep on scrolling down, I get A, I get B, and I get R. A, B, and R. So those are the coefficients. A is the intercept, B is the slope, and R equals 1 is the correlation coefficient. It's perfect. Perfect correlation. Why is the correlation perfect? How is it that the correlation is perfect? Well, look now, which you should have done at the beginning, but I just jumped into making calculations. If you look at the data from the beginning, and let me demonstrate the data. So look at the data. What do you see? What do you see? Think about it. Just look at it. What is the relationship between X and Y? There's a delay in our conversation. Let's see if you can answer me. What's the relationship between X and Y? X and Y. X and Y. With one word? That doesn't look very clean, but it's double. Oops. I'm trying to spell double. Okay, it's double. The relationship is perfect, and it's perfectly double. So think about that. This fact that it's perfect implies that the R is perfect. Perfectly positive 1. Okay, that's the perfection in the matching. But the relationship, how you transform one from the other, or you get one from the other, the relationship is a duplication, a magnification of 2. Okay, that signifies the B is 2. Okay, this is a very simple exercise. You could have even plotted these to see that the R was positive 1, and then you could have solved, since they were on a perfect line, if you plot this, you could solve for the slope between 2 points, and you would have gotten the regression slope, and you didn't have to go through the trouble of anything else. So one point here is always demonstrate or sketch your observations. Okay, you could have easily sketched this and seen that you would have gotten all the dots would have lined up perfectly on a line. Okay, so that's the difference between R, the correlation coefficient, and the slope in a simple example as this. Okay, any questions? So what about this one? What about this one? Can we put this in our financial calculator? Can we put this one in our stats calculator? Actually, not in this kind of calculator. You can actually do this calculation in a HP, an HP calculator. The HP, I think it's an HP2B as well. Anyway, they're the recommended calculators. This one and the HP. Okay, so the TI BA2 Plus and the HP10B, that's what it is. The HP10B. And the HP10B is more expensive. It's like triple the price, but it can do much more heavy calculations. Computations like this, so it can do a weighted mean, a weighted standard deviation, and it can calculate an R for you. But that's fine if you don't have that calculator. I wouldn't give you a lot of values like this one. You have just 3 values to test if you can calculate the mean, the standard deviation, the R. If I give you exercise like this, I probably give you most of the values anyways. Okay, so you should practice making these calculations. And you'll find out, in fact, in this exercise, even though you can't see it as well because each observation has a different significance, a different weight, a different likelihood of appearing, in this exercise it actually does work out that the B is 2. Okay, and the R is 1? I can't remember now. We have to go and look at that. So anyway, you can tell me the B is 2 in this one as well. Okay, so that's my example. So that's the first thing I wanted to tackle, looking at. Okay, then I wanted to what happened to my calculator? Did I lose you guys? Did this get cut off? I don't know what happened. My calculator isn't even. My pad is still streaming. I don't know what you guys are seeing. I don't know if we got community striked. Anyway, let me see if I can I don't know why that is showing like that. I took the phone off long ago. No comments from you guys? No comments? All right. I don't know what happened to you. So my point was that up here, the relationship is double, and it's perfectly double. The perfect part makes the R a +1, perfectly positive relationship, right? When x is 15, y is perfectly doubled by 2. Sorry, x is doubled to make 30. So this is a positive relationship, and it's perfect 1 because it happens again and again. So that slope is something different. Slope signifies the direction, or sorry, the magnitude of the relationship. This is the doubling. R is the perfection. And then I recommended that you try to do this exercise below. You can use the tables I gave you. You can calculate by hand, because this doesn't give, this is not possible in the 10B, in the TI BA2+. But you can do this in the HP 10B. I think it's 2 as well. Okay. So work on that, and I want to make a point, I guess, about these formulas that I'm expecting you to know. The most important thing is just staring at the formula. Using the formula from the top is much more straightforward. Referring to the formulas on top here, much more straightforward. You know, this is the sample mean, this is the sample standard deviation, and then I introduced this, which is, if you stare at this, this is actually like the variance, except I'm not squaring the deviations from the mean. I'm multiplying them, the deviation from the mean for the variable x and the deviation from the mean of the variable y. So it's like if this was x and this was x bar, then this would be I'd be calculating the variance. But by introducing the elements of the pair, I'm calculating what's called the covariance. So this picks up how these variables behave in relationship to each other. To understand better about the correlation coefficient and covariance, I'm going to refer you again back to the video that I provide with the scatter plots at the end of GDS. Okay, make sure you watch that scatter plots video, and I show you how we look at and understand R. Without even making calculations, I just explain what R is picking up as a calculation. So then from here, covariance, what is the relationship between covariance and R? Well, this is it here. Covariance, depending on the variables you use, can be computed, and it will represent the direction and the strength of a linear relationship between two quantitative variables, just like R, except we have trouble understanding if covariance is high, if it's a high or a strong relationship or a weak relationship, because depending when we're looking at variables, different variables, we don't without understanding the variables themselves, we don't really know what high is. Okay, we don't really know what relatively high or relatively low is. By standardizing, so the standard deviation gives you an idea of the spread of the variable, okay, the observations and their spread. By standardizing the covariance, what you do is you reduce the covariance to a scale of R. R is between -1 and +1. And that is more interpretable. It's much easily interpreted. If we calculate an R that's close to +1, that's almost perfect positive correlation. When we calculate an R that's close to -1, it's a perfect negative correlation. Anything between, if it's very close to 0, we say no correlation or no linear correlation. Okay? Now, all I've done here, so this is the simplest understanding of R, it's the standardized covariance. Here is just a variation on the formula where I want to derive this one. This is the one we used last time we met. And I like this one because you'll get the same result, obviously, because algebraically this is the same as this. However, this demonstrates nicely that we're standardizing the value of x and y, averaging them in a way, right? Whenever we see this, we like to say average. Remember I explained that to you? So we're averaging the multiple of these two, and in so doing, we're picking up if x tends to be above its mean, this will always be positive. At the same time that y trends seems to be above its mean, that will make this positive. So a positive times a positive will give you a positive. If instead, when x is above its mean, y tends to be negative most of the time, then these will be multiples that become negative because you're multiplying a positive by a negative, and that'll give you a negative, and you'll be adding a bunch of negatives, and so R will be negative. You see how it works? But if this is not a repeated pattern, and sometimes you have a positive for this amount and a negative for this amount, and sometimes it's the reverse. So if they flip-flop back and forth, the R ends up being close to 0, okay, because they start canceling, positives and negatives start canceling each other out. So they're all the same formula. correlation is a standardized covariance. That's important to know. All right. What else can I tell you about R? No questions? I see no comments, no questions. So what did I say next? I was going to solve some problems. Okay, so let's see. I'm going to upload. I'm going to get out of here. And I'm going to upload Nora. Are you guys there? Write me a quick note. I see 7 are watching, but I don't see you. I don't hear from you. Okay, let me scroll through this. So all of these have videos, except for a few problems, and so I'll start here. So you guys are not here. I don't see any comments. Did I get booted off of YouTube? Oh, it says that 7 of you are here, but you guys are not writing anything. Write me something. Okay, so I want to try this problem. So this problem, which I don't know why there. Okay. Okay, so Michael Jordan's height is 78 inches. And men in general, so I'm going to introduce the population notation now. Men in general have a mean of 69 in their height, in inches, and a standard deviation of 2.8. Women, on the other hand, have a mean of 63.6 and a standard deviation of 2.5. All right, how do we use this information to determine if Michael Jordan at 78 or Rebecca Lobo at 76 is relatively taller? Who's a relatively taller basketball player? So how would I figure this out? My approach would be to, this is a standard approach when you have two sets of data and you don't know, is 78 high, is 76 high? Those looks like Michael Jordan's taller if you just look at those. So if you just look here, it looks like, oh, well, yeah, Michael Jordan's taller, but remember, statistics is about averages and relative measures. We need to incorporate this information, okay? So incorporating this information, the way to do that is to standardize our value, reduce it to standard deviation from its mean, from the measures here. So we'll start with Michael Jordan. So the Z for Michael Jordan is equal to 78 minus 69 divided by 2.8. Okay, make a calculation of that. And then similarly calculate the Z for Rebecca Lobo, and she is 76 minus 63.6 divided by 2.5. Okay, when you make those calculations, you get from Michael Jordan, he gets a value. Michael Jordan is 3.21 standard deviation above his mean, and Rebecca Lobo is 4.96 standard deviations above her mean. So that's what it says below in the conclusion. So that means that Michael Jordan is not the taller basketball player between them. Relatively speaking, among women, Rebecca Lobo is very tall. She's an outlier. She's 4.96 standard deviation above her mean, and so we would say, relatively speaking, that Rebecca is a taller basketball player. Okay? So that's what that says. What else do I want to do? Well, it's going to be 6 o'clock, and I don't know who's here. You guys are not commenting. Do you have any questions from old midterms? Did someone email me about midterm questions? Well, if you want me for tomorrow, please send them in advance so that I can prepare them. As you see, there's lots of technical preparation I have to do, so help me along and send your questions in advance. Let me know what I need to prepare and I will bring it. But without hearing from you guys, I am going to sign out. Let me see if I can say goodbye. There I am. Okay, so goodbye. I don't know why you guys stopped talking to me. I hope they don't cut off the video. Talk to you tomorrow.